fish and the whales and the sharks and the cats in the splash zone. Zing! Welcome to Splash Zone, where we explore the science of our seas. Today we're looking at the plastic we pump into our marine environment and acidification in our oceans. First over to Amber Bronte Sunderland, who's talking to the public about plastics.
After extensive research this week, we will be investigating how well the public are informed on marine plastics and the issues it causes. Due to this issue being very big at the minute and time topical, it's publicised on the news quite a lot, so you'd think the general public would have a bit of an idea about marine plastics. However, my research conducted shows that people know very little about marine plastics and are still yet to be informed despite this ongoing issue. And I'm going to prove it. So today, I've travelled to the University of Hull to find out what people know. Here I am at the University of Hull asking students how much they know about marine plastics. The Earth's surface, do you think is covered by water?
I'd say about 75. 70, 71 I think.
Yeah, it's about 71% of the Earth's surface is covered by water. So Earth's surface may be mainly water, but did you know that over 70% of our atmospheric oxygen that you breathe daily is produced by marine plants? How many tonnes of plastics do you think are produced per year?
Say, what? Tons?
Oh, tonnes of plastic, yeah.
Grams. Millions of grams.
How many millions of tonnes?
I don't, 100 million? I think it's like 600 million.
300 million tonnes of plastic.
Oh, the price is right.
And how much of that do you think ends up in the ocean?
I'd say about 95%. Yeah, 85.
So it's about 8 million tonnes of
8
plastic. Relates to 5 carrier bags full of plastic per metre of coastline for the whole world.
That's very sad.
There's a lot of plastic. 5 carrier bags per foot of coastline is absolutely ridiculous. But what's even worse is that by 2025, this is expected to double. So that's 10 carrier bags per foot of coastline. The input of plastics into the ocean has caused many complications in the marine habitat.
We're in the local town of Hornsea. We've only been here a couple of minutes and we're already seeing signs of plastic bottles and other plastic forms on the beach. A local town like this wouldn't be normally affected by things like this, but it shows the widespread effect of plastics.
As you can see, there's a pile of rubble here. Rubble such as this will leave microplastics in the water, which is not good.
Back to Sam in the studio to tell you more information on this topic.
Cheers, Amber! Those stats are quite shocking and are having a terrible effect on our marine wildlife. Endless research has been done into these effects on a wide range of animals. A team of scientists working in Alaska showed that seabirds are one of the most vulnerable groups due to their foraging habits spanning large regions and plastics collecting in the bays where they live. Corals are another big group of organisms that are at risk due to them ingesting microplastics by accident. They mistake these for small organisms such as zooplankton. The problems that plastic cause and the plastics themselves can be passed through the food chains, causing extreme damage to ecosystems. Now over to Harry and Curtis to talk to us about acidification.
Ocean acidification is the process in which atmospheric carbon dioxide is absorbed into the ocean. This absorption, in turn, increases the pH of the water, making it more acidic and dangerous to marine organisms. Carbon dioxide levels in the atmosphere are only increasing as human population grows. According to the Environmental Protection Agency, in 2014, US greenhouse gas emissions totaled at 6,870 million metric tons of carbon dioxide. This total represents a 7% increase since 1990, but a 7% decrease since 2005. The process in which the acidification occurs is by carbon dioxide reacting with water to form carbonic acid, which causes major destruction to marine corals, crustaceans and other organisms which use calcium carbonate in their growth. Carbon dioxide, produced by human activity, is released into the atmosphere. This atmospheric carbon dioxide mixes with seawater, reacting to form carbonic acid. Carbonic acid releases two protons, which bond with carbonate ions to form bicarbonate ions. The bicarbonate ions prevent calcium ions from bonding with carbonate ions, as H+ or protons are more attracted to carbonate ions. This prevents the formation of calcium carbonate, which in turn then cannot be used by aquatic organisms when constructing their skeletons. Now back to me at the beach last night to tell you more about this subject. Shell-building organisms cannot extract the carbonate ion they need to build their skeletons, as the attraction is too strong, resulting in a reduction in the populations of these such organisms. One case study investigated was that of the common shore crab and the effect ocean acidification has on this crustacean. 2 polypeptides and 1 dipeptide of this crab are affected by the more acidic conditions. The change in pH from 8.2 to 7.7 results in changes in the structure of the amino acid chains, altering their electrostatic properties and preventing them from being complementary to their required receptors. This impacts the pheromone receptors of female crabs, reducing reproductive success of the species. Save our seas!
Save our seas!
Save our seas.
Save our seas.
Save our seas!
Save our seas.
Save our seas!
As you can see below, and preventing them from being preventing them from being of the species.
We're in the local town of Hornsea, and I don't know what to say.
Crustaceans and other organisms which use calcium carbonate in their growth.
Fish and the whales and the sharks and the cats in the splashdown. Zing!